Right, this is our first recording of the use of the Astroscope system, which is a system we use to bring down magnetic holograms of the planets using what we call a magnetic lens. We're not going to go into the details of that lens or how these holograms, or at least how we think these holograms are formed, but we're just going to run through what's sitting on this field now and what a biolocator can actually see in the solar system. So at the moment I'm standing where the lens was, and what was marked out around me is the perimeter of the hologram of the Sun. It stands here as an invisible sphere of magnetic energy which the biolocator can actually locate and identify classic chemicals that make up the Sun, in particular protons and helium, and we can come right into the Sun and douse the core of its Sun itself. Now, in terms of visual photography, there is nothing there, and to see this you need to be a biolocator. But once you're able to respond to all the different fields which represent the actual, are representative of the actual layers of the Sun and the edge of the Sun, it soon becomes pretty clear to a biolocator that you know what this energy entity actually is. So it sits here held by the lens. The lens has captured the magnetic fields from space in the same way an optical telescope does, and then around the Sun hologram are all the planet holograms and everything else that's in the solar system, including the extraterrestrial craft and stations that we've been talking about. And it's just then a matter of walking around the Sun and actually locating all the different energies from the different heavenly bodies. Each heavenly body will have a characteristic chemical composition which in turn can be identified as a characteristic magnetic energy profile. So very simply then, out here the small tape is indicating the position of the Mercury hologram. This is a very dynamic system. The planets will move and they can be referenced to planetaria on the internet, and the two of them check out. So for this moment in time, that's where Mercury actually is, and we'll be keeping this system up for the next couple of weeks while we track the Comet Ison. Just outside of that is Venus, and that's much larger, and again the problem is with some of these holograms, the sizes don't directly sometimes represent the sizes of the planets, nor do the astronomical distances, but that's quite convenient for us because it enables us to, if you like, walk around the planets in a very short sort of space and do incredible detailed analysis on them. So just over there, that one there with the flag in the middle, there's a hologram of Venus, and again the clouds of sulfuric acid, all the gaseous atmosphere can actually be detected and marked out in quite detail. Then over there with the green tape, that's planet Earth. Again, you can pick up the iron core quite easily through the dowsing, and the difference with our science-based dowsing of biolocation is that we douse vertically as well as horizontally. Traditionally, dowsers walk across a field and find energy lines. In our techniques, you have to be able to douse vertically and mark them out as well. Alongside that is our moon, and that's moved where the tape is showing that over the last couple of days it's moved quite a distance. We haven't marked that out yet, but the rotation of the moon we can actually sort of plot as we do it. Then looking straight across out here is Jupiter. Again, the astronomical distances are not represented, the linear scale of them and the size of the holograms are on two different scales, but conveniently for us the astronomical scale is reduced quite considerably, but the holograms come up on quite a large scale, again allowing us to access. So Jupiter will be picked up on helium, water, you'll pick up the moons around there quite clearly, and it's a giant planet, and the size of the hologram normally is related to how its mass and its sort of magnetism. And sweeping across due north, that's Mars. The tape there with the cane planet Mars. Again, we'll pick up red oxide as one of the tracer witnesses to use. And you can pick up the moons, the 2 moons, which are quite close to Mars. So that's one sector. Just in that direction, between Earth and Venus, will be Uranus and Neptune. We haven't located those. And then just over there, if you can see that white flag, that's Pluto. And then just that fence over there, we haven't marked it yet. That will be the edge of the solar system, where you'll pick up several lines that will be the heliopause, which is the sort of bubble that forms around the solar system. So we've set this up to leave it for a couple of weeks, and we'll be monitoring what's going on in the solar system. And of course our main interest is tracking Comet Ison, which is just marked out very roughly there by canes. We can see the line of canes. We've been tracking that. Today is the 31st of October. We've been tracking it since Monday, and following its movements as it will track around the sun and back out. The perihelion will be probably around here, around 3rd week of November, and we'll be tracking it all the way in before it shoots back out past the Earth, coming down at an angle and sweeping back out. And this morning, just to make sure that we didn't confuse or get this comet wrong with Encke, I think it's pronounced E-N-K-E, Comet Encke, we located just there, and we've marked that out in quite some detail, and although the canes don't really sort of reveal that detail. So that's the Astroscope. Again, it doesn't look much to look at because it's visually marked out with tapes, but when you're a biolocator, in those tapes are enormous details about the composition, what's on the planets, what's in them, and of course that's where we pick up all the alien craft and ships stationed throughout our solar system.